And my name's James Anderson. You can find me on Twitter at the Database Avenger. I also blog at databaseavenger.com. Try and get one out every week. Don't always make that. Today we're talking about row group pressure and row group pressure in Columnstore indexes. So we have a Columnstore index. It's still just a table. We're still going to query it in the same normal way. I'm not going to write any special SQL. Still going to get the same data back in the same rows that we expect, but it's behind the scenes. It's stored in a different way. So it's that I'm going to talk about, and one of the problems that can happen with that is row group pressure. So let's say with this table we've got 3 columns. So ID, name and address, and we put a Columnstore index on that. We've got no other indexes on the table, and we're just going to put this Columnstore index on. The first thing that does is it's going to split our data into what are called row groups. Now these row groups basically segment our data into, hopefully, segments that make up 1,048,000 rows. So each column has one segment per row group, and each segment should have just over 1 million values in it. So if we have a query like this, and our table is called Columnstore index underscore test, and we're selecting name, and we want all the names that start with the letter J. Now the good thing about Columnstore indexes is that straight away we only get the columns back that we need. So we only need the one column name, so we've already knocked off 2/3 of the columns. In the old rowstore way, we would have used a tree to zoom right down to the rows we wanted, but we still would have brought back all the rows only if we wanted a subset of those rows. So Columnstore indexes are better that way. So we're only looking for the ones that start with J. Well, these row groups have metadata, and it's this metadata that the query engine will interrogate to see which one of the segments it needs to use. So based on this, it can do something that's called segment elimination, partitioning in the old rowstore way. So now, with the use of that, instead of reading all 15 segments, we're now just reading the one segment to get those values that we want. So that's basic column stores. Rowstore is still good if we're doing OLTP type stuff, kind of like singleton lookups. Columnstore is really good for scanning huge amounts of values within our specified range. So what's row group pressure? So these row groups, as I mentioned, can be about, we want them to be about . So if our row groups have less data in it, means we have to pay the cost of added overhead of reading all those extra segments. Now the 3 main things that can cause this, one is parallelism. So if we're building our index, if we were doing it serially, so just one thread, we'd be building each one, and all of our segments would be perfect. But once we got to the end of the data, we wouldn't have exactly the amount of data to finish that last row group. We're always going to have one at the end that's going to be partially filled. But if we were doing that in parallel, we might end up with 8 or 16 possibly, depending on the cores that we've got available. So now we've got 16 row groups that have got not as much data in them as we want. Another one's memory. To build a segment, we have to fit all the values in memory at the same time. If there's a lot of stuff going on the server, we may have a problem there. So it just has to stop building the segment at that point. Therefore, we get another row group with not an efficient amount of data in there to get efficient scans. But today I'm talking about dictionary pressure. So dictionary encoding used for strings. So instead of storing the actual strings in the columns, we store the actual strings once in the dictionary and store a very small code in the columns. When we scan the data and find the codes, we look the actual values up in the dictionary. That does mean this dictionary can become quite a hotbed for contention, but it's a very good form of compression. You save a lot of space that way, backups, memory. We're going to get a lot of pluses from that. Now, this dictionary is limited to 16 meg. If we've got lots and lots of data, lots and lots of different names, we're going to overfill that dictionary. So what happens in that case is segments that have got the most distinct values, we're going to build these local dictionaries. So all the other segments are going to use the global dictionary. These local ones, they're going to use their own bespoke dictionaries to take the pressure off a global dictionary. But if we have a segment that has two values, too many distinct values, the local dictionary is going to overflow. So what do we do in that case? Well, each segment, the rules are, the segment can only ever reference one local dictionary. So our only option really is to split the row groups. So now we've got two local dictionaries for that same amount of data, but we've got dictionary pressure because we've had to take some data out of one group, which is going to give us some somewhat inefficient scans, but at least we get our dictionary encoding. So to try and demonstrate that, I wrote this horrible query. Don't try and read it, it's not great, but basically, just to give you an idea, all it does is just inserts 20 million semi-random text values just to try and recreate this problem. Now, Nico Neugebauer has a really good script, a script library for Columnstores on GitHub, so you can go there and grab that. And some of the scripts he's created here give us a real good insight into our column stores. So that test one I created, I used one of Nico's scripts. And this one shows us the row groups. So we can see all of my row group IDs there. We can see that they're all compressed. And when we look at the total rows, we can see that some of them have got the perfect 1,048,000 value, but some of them don't. And so we've got row groups here with less than that desired amount of rows to give us really good efficient scans. Now if we look at the segments, what we'll see is those row counts, if we look at the ones with the good level of row count, so the 1,048,000, we can see that they share the same secondary dictionary ID. If you look in that column, you can see the ones with good values share the dictionary. But if we look further down, so say segment ID 15, we can see that one's got quite a low amount of rows in there, half of where we want to be, and it's got its own local dictionary. So that horrible query I showed you earlier has managed to recreate this dictionary pressure. This just shows you that this could happen, and if we're loading data multiple times throughout the day, this could happen a lot, and we could mix these problems. So we could have dictionary pressure along with parallelism pressure, along with memory pressure. So we really need to keep a good eye on any row group pressure in our Columnstore indexes to get the most out of those scans. Well, thanks. Hope that wasn't too trying to cram everything in pretty quickly. I think we're about